Alright, this is Leontief video 3. So the goal of this video is to look at some notes, or to make some notes, or to look at one specific thing about I minus M inverse. So we're focusing on this case. So we'll say in the case where I minus M is invertible. So the point being that we use this matrix, this inverse, to calculate things. And we use this to do, in the case where it works, to find the production. But the point being that this inverse has a use in its own right, beyond calculation. In other words, more specifically, the matrix, or let's be more specific, the entries in I minus M inverse. These are useful in their own right, without necessarily multiplying them by a d. So what we'd like to do is take a look at that. So let me number that one. So we can do this. This can be done very succinctly, or it can be done sort of drawn out a bit to really get to the point. So let me draw this out a bit, because it'll help reinforce some of our linear algebra, etc. Right? So let's take a look at a specific example, right? So let's say, not too specific, but an abstract example that'll get to the heart of the matter. Maybe a general example might make more sense. That's okay, it doesn't really matter how we phrase it. Okay. So suppose now we have a particular M and we have a particular D. Let's say we have some fixed M and some fixed D. I'm not going to pick specific values because it doesn't really matter, but suppose that they are fixed. Right? And then what we'll do is this. Suppose that we increase the demand, the external demand, for product 1 by 1 single unit. So I suppose the external demand for product 1 increases by plus 1. I'm sort of being redundant by saying increases by plus 1 unit. See, the external demand is now, let's call this D prime. This would be the old external demand. It's not a derivative, it's just notation. Plus 1, 0, 0, because we added 1 unit of product 1 to that external demand, right? So the question is then, how does P change? Right, let's take a look, right? Now we have P prime, right? This is, say, the new production. So the new production is that matrix times the new demand. Right? So let's see what this is. This is multiplied by this, and this distributes because it's a matrix times a vector. And this one here, of course, was the old P. So this is telling us that new production is the old production plus this. So this is how production changes, right? Now, the question is, what does this represent? What does this right-hand side, this piece right here, represent? So it turns out that this product, when you do matrix multiplication, this product gives us the first column of I minus M inverse. This is just a consequence of doing matrix multiplication. There's nothing special going on there. So what this indicates is the following. Is that this first column tells us how the production must change. So this first column tells us how P must change when the external demand for product 1 changes by +1. So I want to circle a couple of 1s here. The ones you want to focus on is the first column tells us how P must change when the external demand for product 1 changes by +1 unit. So this leads to a general rule. So let me clear the screen, I'll give the general rule, and then we'll look at an example, and then we can sort of dig in and play a bit. So 3, general rule. Is the jth column of I minus M inverse indicates how production must change if the external demand for product J changes by +1. So take a look at an example because we can dig even just a bit deeper. So go back to the very first example, first video. This was M. So if we find I minus M inverse, this is what we get. This was done in MATLAB. I'm not going to show a calculation. I'm going to give a fair bit of detail here because it's helpful. And I want to make some interesting points about these values. Oops, 6.1. Let me fix that. Oops, this is a 1.2850. This is a 0.7400. These are approximate to 4 decimal digits. Notice that the main diagonal are all bigger than 1, which is a reason for that. But so what this says is, suppose the following happened, right? If the external demand for product 1 changes by +1, what we do is we look at the very first column. So we look at these values. Those tell us how the production must change. So production of product 1 must increase by 1.2660. Of product 2 must increase by +0.4375. And for product 3 must increase by +6.144. Oh, sorry, 0.6144. Right? This is in order to compensate, right? In order to create that change, right? This is to do that. So in other words, if say that, I don't know, they're going to make this up, if the government gets a request, says, hey, the external demand for product 1 must go up by 1, then the government would call industry 1, sector 1, and say, increase your production by 1.2660, and then product 2, and then product 3. Now, Likewise, we could say also, I'll list one more so we see how this works per column. If the external demand for, say, product 2 changes by a +1, then what we do is we look at the second column. So we go right there and we say the production of product 1 must change by 0.3128, of product 2 must increase by 1.2850, product 3 0.7400, and so on. Same for column 3 and product 3. Right? Now there's an additional note we can say, because we could even drill down to a specific entry. Right? We could say that the ij entry of I minus m inverse indicates how production of I must change if external demand for product J changes by +1. So, for example, if we look in, say, the third column at this value right here, 0.5473, right? That value tells us what that means is if external demand for product 3, that's the column, changes by +1, the production of product 2 must change by +0.5473 to compensate. Now, there are two other interesting facts about this. So what I'll do is let me clear the screen, put the I minus M inverse back in the upper left, and then make those last two comments. So same I minus M inverse. I didn't rewrite M, not necessary. So these two final notes is this relationship about these increases. It's a linear relationship because it's matrix multiplication. So what this means is the following. Suppose in the matrix above, suppose I ask a question like this. The external demand for product 1 decreases by 7. How must the production of product 3 respond? So if the external demand for product 1 is changing, that's the first column, right? So this is the column that we're interested in. This is what happens when the external demand for product 1 changes. So let me just number things. So this is the external demand for product 1. That's the yellow. That corresponds to the yellow column because it's sort of more of a mustard, right? So product 1 change. External demand for product 1 change. Let's be really, really clear here. That's the first column. The third entry, right, because we're looking at how product 3 must respond, we're looking right here. So product 3 response is the 0.6144. Now, keep in mind what that number means is, so far we know, if the external demand for product 1 changes by +1, then product 3 must change by plus 0.6144. So the fact that it's linear means that if the external demand for product 1 changes by -7, because it decreases, product 3 must change by -7 times 0.6144. So that's the linear relationship, because think of it as just step by step. If it goes up by 1, it changes by plus 6.144. If it goes down by 1, it changes by negative 6.144. If it goes down by 2, it changes by that twice. So that's the first fact. The second fact is just more of an observation, is we notice that the main diagonal let's say the main diagonal entries are all greater than or equal to 1. This is not coincidental, right? So take a look at a specific example, right? Say take a look at this one right here, 3, 3. Keep in mind what that means, right? What that means is, let's think about what's happening. If the external demand for product 3 goes up by 1, what does sector 3 have to do? Well, it has to produce that 1 unit for the external demand, but it also has to produce additional product for all of the internal demand. So we could say, for example, if the external demand for product 3 goes up by 1, what must sector 3 do? Well, it has to produce that 1, because sector 3 produces product 3. But there's also a bunch of internal processing that's going on. So there is also all the internal let's say interaction, because there's a lot going on, right? In other words, the product sector 3 doesn't just produce 1 more, because sector 3 needs things from sectors 1 and 2, and those need things from sector 3, and so on and so forth. There's this big intricate interplay going on. So there's also all the internal interaction. This culminates or leads to the additional 0.62, right? So thus it's definitely going to be the 1 and probably more. Right, so I say it was why it's greater than or equal to 1, almost certainly greater than 1, because of the producing the 1 and then all the internal stuff that's going on. So those are the notes I want to make about I minus M inverse. So let me end this video here.